I'm Radek Šmíd. I work as a DevOps engineer in Cloudera, and as mentioned, I am sick today, so I'm sorry I couldn't attend in person, and big thanks to the organizers for letting me present online. As you can see, my slides are with this purple color with Tycoon logo. That's because Cloudera got recently Cloudera acquired Tycoon recently, and I didn't get the new template for slides. So sorry to any Cloudera people listening right now. Cloudera is a nice company, and we're hiring. We are hiring. So if anybody is interested, keep in touch with anybody from Tycoon. So my talk will be divided into 4 parts. First, I want to touch on why we need autoscaling in the first place. Then I will compare cluster autoscaler versus Carpenter. Then I'll deep dive a little bit into the code of cluster autoscaler, because cluster autoscaler is the main focus of this talk. And then I'll talk about some gotchas, some things that are good to know when using or implementing your own cluster autoscaler. So why do we need autoscaling? The reason is quite simple and intuitive to adjust to peaks and dips in demand, infrastructure utilization. But most importantly, as all the finance people will tell you, we want to save money. In fact, maybe we can save so much money that we can almost afford the people. Well, every talk that you find about autoscaling usually starts with the comparison of scaling horizontally and vertically. But I know who you guys are. I've met you on a few of these meetups, and I know that you guys are mostly Kubernetes experts, so I will not go into that. Instead, I want to present a different point of looking on autoscaling, and that's like a more Kubernetes-centric one, because basically, if we divide it up, we can scale pods, nodes, and clusters, and each of those we can scale with more resources or more pods. If we put it into a nice table, this is where the next wonderful speaker is located with his Keda. This is an interesting part of the table where we add more resources to pods. That means like modifying the resource requests and limits for Kubernetes objects. And in the latest version 133, there's a new feature in Kubernetes that's enabled by default that allows in-place pod vertical scaling. And so I thought that's something I'd like to mention also, since it's a relatively new feature. But other than that, like, you can adjust these usually by hand. Another interesting thing is this part of the table where the nodes, where we want to resize the nodes on a running Kubernetes cluster. This is possible. We've done it a few times in Tycoon on our clusters, but it's not really a good time to say. It's not really too desired. I don't know about any automation that allows this to do it fully autonomously. I'm happy to be proven wrong. So I wrote manual here. This part, more resources for a cluster, is the same as more nodes for the cluster, because adding nodes to the cluster is, of course, giving more resources to the cluster. And I'm going to be talking about these two, especially this cluster autoscaler. And to finish up the table, there are ways you can scale to multiple clusters. So what is Cluster Autoscaler? Cluster Autoscaler is a project managed by special interest group Autoscaling. It's part of Kubernetes itself on GitHub, and it picks from predefined sizes, node groups, and adds nodes to your cluster depending on the need. It's kind of a old solution, let's say, compared to Carpenter. It's pretty stable, reliable, and it works with many cloud providers, which are implemented straight by the community inside of the project. Opposed to it is the, let's say, newcomer that's taking it on. But in reality, it's also managed by SIG Autoscaling. Both of them are recommended by the official Kubernetes documentation, and Carpenter was donated by AWS to CNCF in 2023. It's a graduated project, and it supports something called auto provisioning, which basically means you get just-in-time nodes, JIT nodes, which are exactly the size you need them to be. It is mainly AWS-centric, but expanding. There are many forks of the original project maintained by various companies. For example, Azure manages its own Carpenter provider. Zoom manages the one for Oracle Cloud, and so on. So there are possibilities. It's just not as much as Cluster Autoscaler. I will be talking mainly about Cluster Autoscaler, and I want to use this talk as part of a motivation that not everything needs to be run with Carpenter. I think Cluster Autoscaler is a really nice project, and I wanted to introduce it a little bit and deep dive inside of it, because in Tycoon we implemented our own provider inside of Cluster Autoscaler. We didn't merge it to upstream, but we maintained the fork and use it to scale our clusters. So back to Cluster Autoscaler. So it's a Go project. It releases on the same schedule with Kubernetes, so it's very you know what to expect from it. The images are freely available and downloadable from cubes.io. This is the latest one. From our experience, Cluster Autoscaler works across Kubernetes versions, and it's really and it's pretty robust in this kind of versioning way. It's pretty extensible. There are many knobs you can turn inside. Some managed providers only provide you the Cluster Autoscaler, but simplify its deployment, which is nice if you don't know what you're doing. But if you know what you're doing, there's so much stuff you can configure there. And I wanted to kind of bring up, shed some light on this a little bit. So that's the baked in part. So how does it work? Basically, Cluster Autoscaler has a loop which it runs. It has 3 parts, and it runs this 2 times in each loop. So it observes, it simulates, and it acts. And then it observes again simulates, and acts. First time for scaling up or provisioning. a second time for scaling down. If we take a look at the first part of the loop, it observes pods that have a schedulable condition set to false. So you all know conditions inside of pods when you describe them with kubectl, and the reason must be set to unschedulable. And then there's the time when the pod got created, and it's clever and waits a little while until the pods are of some age. So that means it doesn't spin up new nodes just because the scheduler is a little slow today or something like that. Then it runs the simulation part. It has a scheduler library inside, but it's a little simplified when compared to the real scheduler. There might be multiple runs of this simulation required, but it's quite fast for a few seconds maybe. And then if new node would help, it will scale one of the node groups. You can define more node groups, but more on that later. Then it acts. The last part is calling the cloud provider specific logic. The specific logic is implemented by the cloud provider itself, and those are the parts I showed here. Then we have the second part of the loop, which is consolidation. That means scale down. Again, it observes nodes that have some less than 50% of allocatable CPU or memory. By default, it's 10 minutes. They have to be below this threshold. By the way, the loop, it runs every like 10 seconds, I think, by default. Against the node, again, the nodes must be fairly of a little bit of age, so not to destroy them immediately. The simulation and the action is similar. Well, the difference here is when it acts, it safely drains the node, which is not your responsibility if you're implementing the provider-specific code. Basically, the cluster autoscaler cares about all of this eviction from the node, which is quite nice. If we take a look into the code, this is the loop. And as you can see, autoscale all the way. It autoscales forever. And in the scan interval time, it runs the loop. The first part, I'm not going to go through all of them. I'm just going to go through the scale up part. The first part is observing. So it updates the cluster state, and it calls it as a method on this object. It counts the unschedulable pods and filters them. So now we have a list of pods that are unschedulable. And that way we can decide, is there more of them? Would it help if we would add a new node? So we can iterate over this this pods part. I kept the comment in here because I found it very amusing that this part is from before the migration, so let's keep it for now, which is typical. And it has a snapshot of the cluster as it looks right now, and adds the pod inside and tries to simulate what would happen inside of that cluster, how it would work. And if it would help, And if it would work, again, it calls a method called scale up, which calls the provider code, which increases the size of the node group, which adds the new node there. So maybe this all looks very simple to you. Maybe it looks a bit convoluted. But anyway, if you ever need to implement this, the documentation on it is a bit dodgy, right? There's not too much of documentation for this project, which is a shame. There's only a big FAQ. But what you need to know is these are the required things to implement. So basically, you need to implement a struct with this that matches this interface. And it has a fairly simple methods, right? This is understandable. This is just a getter for name, return all available node groups, check if check what node group is this node in, get how much resources are left in the provider, clean up, refresh the state of the provider. Fairly understandable interface, right? And the same thing here with the node group, where we can increase or decrease the size or delete specific nodes. A provider needs these to have the ability to work with this logic, with this advanced logic of checking if the nodes are failed, deleting them in that case, and stuff like that. One important thing to implement is this template, because the provider doesn't just magically know how the nodes will look. You need to be able to somehow pass the information about how the node will look like. What will be its annotations? What will be its stains? Or what will be its allocatable space? Like will it have 5 gigabytes of RAM, 12 gigabytes of RAM, stuff like that. So when you run it, the logs are also quite nice. There's a simple klog library written also in Go that's used. You can see that it just does the filtering, calculates the unneeded nodes. Then it says, okay, these are manual edit. We shouldn't really touch those. We in Tycoon use annotations to mark those. And it marked here that this log is a CPU that has been idle for quite some time, and it's been quite low, but Autoscaler is refusing to remove those because some pods cannot be removed. I'm gonna get a bit into this later, but basically the trick to realize here is if pods don't have if pods don't have a controller, something that's owning them, like a deployment or replica set or stuff like that, or if the pods are using local storage, for example, then by all logic, right, it's not safe to delete those. So there are ways to work around it, but it's just something to keep in mind. There's a bunch of parameters you can set for the cluster autoscaler when you run it. And you can just run it with a Helm or like as a pod. It's fine. Apart from the obvious need to connect it to your Kubernetes and the obvious need to connect it to your cluster provider, there's a lot of parameters that allow you to fine-tune how it works. For example, how long should the autoscaler wait after a node has been added, or how long should Autoscaler wait with other scaling after it has been deleted or after it has failed? How long do we need to wait how long do we need to wait for it to be under the utilization threshold, which is like the 50% CPU? How often should we scan? Stuff like that. So there's one more interesting thing that's called expanders here. I want to talk about it. So what if you have multiple node groups that can be scaled up? So let's say the simulation runs a few times, says, all right, we can scale this node group or this node group. How does the autoscaler know which group to pick? And there are strategies you can use or you can specify, which you see here. Depends on your needs. So these are the expanders, and now we move on to the last part of the talk, where I'd like to talk about some nice things to know or nice things to realize. One common misconception is that the cluster autoscaler provisions new nodes when there is high usage. So that's not true, because it provisions when there are unschedulable pods. These can be very different. These can be two very different things. Your pods might have too much requests, which they are not using. So that means the cluster will be at like low real utilization, but it will need to provision more nodes. Another thing is that CA optimizes cost or minimizes waste, which sounds like something that's very plausible, but it doesn't work magically by itself. It depends on, again, how you set your requests and limits, and how you define your node groups. And of course, horizontal pod autoscaler, most important part. Next speaker will definitely touch on that a little bit, I would assume. Cluster autoscaler, when cluster autoscaler provisioning is not working, it doesn't need to mean that the cluster autoscaler is broken. Now that you know how it works deep inside, of course, you know that maybe quotas can play a role inside of this. Or maybe the API of the public cloud is not accessible. Maybe network problem, maybe they are down. And if the consolidation is not working, that's the most common issue. That means scale down. For example, you can have pods with local storage. You can have type PDBs. Maybe you have pods that are not backed by a controller object. Thing to remember is this annotation, which is by Kubernetes a well-known annotation, and it is safe to evict. And any object in Kubernetes that has this is then treated by Autoscaler as like, sure, I can destroy it. So thank you for your attention. It's been a lovely 20 minutes. I wanted to touch a little bit on this cluster autoscaler project, which I think is quite nice. And actually, it was a pretty good time implementing all of these interfaces for it. And if you ever come across the need to use this, then I would recommend it personally. So thank you for your time and enjoy the rest of the meetup.
Can you hear me? Yes.
Yes.
Okay, we have few questions on Slido. First, why did you implement your own cluster autoscaler?
I wanted to. Well, that's a very very nice question. We implemented our own provider inside of the cluster autoscaler. because the way our product works is basically we are a cloud provider, and we can create the nodes for your for your managed Kubernetes clusters. So we kind of need it. We don't use managed Kubernetes by other providers. We are the provider, so we wanted autoscaling. We needed to implement it. That's it.
Okay, we have second questions. Does CA consider the PDBs for discipline budgets?
I don't think it. I don't know, to be completely honest, but I would guess that it doesn't really consider them when doing the simulation. So that's why you may run into problems when you have a lot of those set. But don't quote me on that.
Okay, next question. How well does it handle when the pod eviction takes a long time before of some custom eviction logic? For example, when a webhook blocks the evictions for about 20 minutes.
Yeah, exactly. So this is exactly the typical problem you might face. Some action can take a long time, depending on your depending on the type of your pods, depending on your configuration, and depending on your cloud provider, because not all cloud providers, for example, have the same speed of adding a node. So this is when the knobs come in. You can handle that after some time. If you are not able to evict the node comes into a failed state, and then Autoscaler uses this inside of simulation to know, like, can I reschedule? Should I add new node and stuff like that? So you can, of course, you can define the times, the timeouts for stuff like this.
Next question is the condition whether a pod could be moved customizable? There are hard-coded rules.
Whether a pod could be moved. So is the condition whether
I can read it again if you want to.
Yes, please.
Is the condition whether a pod could be moved customizable? There are hard-coded rules. Are there probably hard-coded rules? Who asked the question?
Yeah, well, the simplest way to answer this is it's customizable to some extent with these annotations and things you can add on nodes. So the simplest version of this is the safe to evict annotation that's there by default. So that just says, like, you cannot move this pod, but I believe there are ways you could customize this a little bit, but I'm not sure how deep would this go.
Okay, that's all on Slido. Do we have any questions in the audience? I suppose not. So thank you. You are our first speaker online.
Thank you very much. I hope you guys enjoy the rest of the meetup, and I hope to see you on some of the next meetups in person again. Thank you.
That would
Bye.
be lovely.